Welcome to this first video tuition lesson. I certainly hope it's going to help you with your GCSE. Okay, let's kick off by looking at what we mean by multiples. Well, multiples are really all those numbers in the times table of any number. Here, for example, I've listed the first 4 multiples in the 3 times table. 1's 3 is 3, 2 3's are 6, 3 3's are 9, 4 3's are 12, and so on. The multiples will go on forever. Here in this list, I've listed the first 4 multiples of 13. 4 13's are 52, so you can describe 52 as the 4th multiple of 13. 39 you can describe as the 3rd multiple of 13, and so on. These are all in the 13 times table. You could look at the idea of multiples in this light. 156 is a multiple of 13. It is also a multiple of 4. It is also a multiple of 3. Why? Well, because these 3 whole numbers all multiply together to give 156. Another way of looking at it is what I've done here. This looks very much like the 21 times table. 21, 42, 63, 84. These are all the multiples of 21. So in other words, 84 is the 4th multiple of 21. A very easy idea. Now let's look at what we mean by factors. The factor of a number is a number which will divide exactly into that number and leave no remainder. Simple as that. Here in this first example, I'm looking at the factors of 20. Well, it's very important to realize that 1 is going to be a factor of 20 because 1 divides into 20 times, and the number itself, 20, is also a factor because 20 divides into 20 once. So this is a very important pair of factors, and this is actually called the first factor pair of 20. Then we go up to 2. Well, 2 certainly will divide into 20 10 times. 10 will divide into 20 twice. So here we have another factor pair of 20. When we try to divide 3 into 20, well, it will not divide exactly. So we can't use 3. So we go up to 4. 4 will divide into 20. How many times will 4 divide into 20? It divides 5 times. So 5 is another factor of 20. These 3 pairs are 3 factor pairs of 20. So altogether, 20 has 6 factors. In this next example, I'm looking at the factors of 90. Here I've started by looking at 1. 1 times 90 is 90. Very important again. Then I go up to 2. 2. How many times does 2 go into 90? It goes 45 times. So 45 is a factor of 90. 3 will divide into 90 30 times. So 30 is a factor of 90. And so on. If I try 4, 4 will not divide into 90 exactly. So I have to go up to 5. How many times does 5 go into 90? 18 times. And so on. Here I've got 1, 2, 3, 4, 5, 6. 6 factor pairs of 90. So altogether 90 must have 12 factors. Now we're going to move on to looking at a special type of number in mathematics. There it is on the screen, called prime numbers. Now, these are very, very special numbers and very important in mathematics. First of all, let's see what we mean by a prime number. We know what a factor of any number is, and we know that many numbers have more than 2 factors, but prime numbers only have 2 factors. Let's look at a prime number. 13 is a prime number. Well, why? 1 divides into 13 times. 13 divides into 13 once. So there's the first factor pair of 13. If we try 2, how many times does 2 divide into 13? Well, it can't exactly. And if you go into 3 and 4 and 5 and 6 and so on, none of which will divide exactly excuse me, into 13. So you are forced to conclude that 13 is a very special type of number that only has 1 factor pair, or only has 2 factors, 1 and the number itself, 13. And it's that which defines it as a prime number. Let's look at this next example of 43. 43, if you try to find any other number higher than 1 which divides into 43, you try 2 or 3 or 4 or 5 and so on, none of them will divide exactly into 43. And again, you're forced to conclude that 43 is a prime number because it has this special quality that it only has 2 factors, 1 and the number itself, 43. So it is another prime number. I've written out here the first 6 prime numbers, and when you first look at these, you are quite tempted to think, oh, it's just the odd numbers. Well, it can't be, because 2 is certainly not an odd number. In fact, 2 is the only even prime number. And if you go along the list, 3, 5, 7, oh, 9 is missing, 11, 13, 15 is missing. So 9 and 15, which are odd numbers, are certainly not prime numbers. Well, let's ask the question, why is 9 not a prime number? Well, certainly 1 times 9 is 9, but if you look at this, you will see that 9 has another factor pair, 3 times 3. So in actual fact, 9 has 4 factors, and so it's not in this list of prime numbers. Okay, we're now going to show you why prime numbers are so important. And this was actually came up as a GCSE question this year. There's a question about this. Well, this title says numbers written as a product of prime factors. First of all, let's make clear what we mean by a product. A product means a multiplication. So if I said to you, what is the product of 7 and 3, you would do 7 multiplied by 3, or 7 times 3, 21. So the product of 7 and 3 is 21. Very easy idea, just a fancy name for multiplication. But we can use it in a very neat way with prime numbers and prime factors. Now before I go on again, I'll just try to give you a flavour of the specialness of prime numbers. There is an idea written down by a man called Goldbach, and he said that any numbers in the world can be written down as a product of prime factors. I mean any number, all numbers. And the fact is, it is true. We found no exceptions to this rule. No one has proved Goldbach's conjecture, and if you can manage to prove it, you will be a very rich person, because I think there is a £1 million prize money for the first person to produce a proof of this conjecture. Anyway, it seems to work. Let's start off by giving you an example. Let's look at 30. I want to write down the number 30 as a product of its prime factors. How do I do it? This is how you do it. You write 30 like this, and you start dividing 30 by the very first prime number, 2. I know that 2 will divide into 30 because it's an even number, and it goes 15 times. Now 15 is not even, so I cannot continue dividing by 2. So I go up to the next prime number higher from 2, which is 3, and 3 certainly will divide into 15, and it will divide 5 times. Now these 3 red numbers, 2, 3 and 5, they're all prime, and they've all broken up 30. And if you now multiply them together, in other words a product of these 3 prime factors, you find that they all come to 30. 2 times 3 times 5 is 30. 2 times 3 is 6. 6 times 5 is 30. Or 3 times 5 is 15. Times 2 again is 30. You have rewritten this number 30 as a product, a multiplication, of its prime factors. Let's look at an even larger number. 1000, as you can see it's coming up on the screen. It's a bit difficult moving these bits of paper around. Okay, here I'm going to break up this large number, 1260, into its prime factors. And here they are. Let's straighten the page a bit like that. There we go. Like that. Okay. Well, 2 certainly will divide into it because there's a 0 on the end, so it's an even number. And 2 will divide into that 630 times. Now, this is again even, so I can continue to divide it by the lowest prime number, 2. 2 will divide into that, and it'll go 315 times. Now this 5 on the end shows me it will not divide by 2 again, so I move up to the next prime number from 2 to 3. 3 certainly will divide into 315, and it'll divide 105 times. This again will divide by 3. 3 into 10 goes 3 times, 1 over 3 into 15 goes 5 times. Now 35 won't divide by 3, so I now have to move up to the next prime number, 5, divide it into that, and I get 7. Now I need to stop there because all of these numbers, they are all prime numbers. Now when I multiply those prime factors together like this, there they are, I get 1260. I have now broken up this large number, 1260, into a product or multiplication of its prime factors. 2 times 2 times 3 times 3 times 5 times 7. These are all prime numbers, and they are all factors of this. Sometimes you see this written, because you've got 2 times 2 and you've got 3 times 3, in a shorthand form of 2 to the power 2 times 3 to the power 2 times 5 times 7 equals that. If you don't believe me, do this multiplication on your calculator and you'll be astonished to find that it comes to that. But you have used prime numbers only, prime factors only for this. Let's do another one. Let's look at 172. Well, this 2 on the end shows me it's even, so I can immediately begin to divide by the lowest prime number, which is 2. 2 divides into 172 86 times. This 6 on the end shows it's even, so 2 will divide into it again. 2 divides into 86 43 times. Aha! 43. Now I will not find anything that divides into 43 except 43 and 1. So that's a prime number. I can go no further with the division. I have to stop there. So I have now broken up this 172 into a product of its prime factors, and there they are. 2 times 2 times 43 is 172. So these are all prime factors, all the prime factors of 172. Sometimes it's written like this: 2 to the power 2, because there's 2 of those being multiplied together, times 43 is 172. Now, in this year's GCSE exams, there was a question that asked you about the highest common factor, and you had to use prime numbers. It didn't say use prime numbers, but certainly that's what the intention was, to find the highest common factor of some numbers. We're going to do this question at the very end, but first of all we need to understand clearly what is meant by the highest common factor. And to do this, rather than talk, I'll give you an example straight away. Let's imagine, let's move that up a bit. Let's imagine we're being asked to find the highest common factor of 45 and 60. Well, common factors, we need to think about factors. So if I was to write a list of all the numbers that divided into 45, here they are, the factors of 45: 1, 3, 5, 9, 15, 45. Don't worry about the colours at the moment, I'll explain that in a second. But they are all the numbers which will divide exactly into 45. Don't forget, 1 must begin the list and 45 must end the list. They're the factors of 45. If I now write down all the factors of 60, it's quite a long list. Here they all are there. Don't worry about the colours at the moment. Must begin with 1, must end in 60. I have written down all the factors of 60. Now the highest common factor is the biggest factor which is common to both lists, which is in both lists. And clearly you've probably seen why I put these colours in. 15 is common to both lists, and it's the biggest factor common in both lists. And so we say that the highest common factor, let's move that up a bit, so the highest common factor of 45 and 60 is 15. Now you will notice, I hope this has come out okay, that I have put in blue here 5 and 3 in these two lists. The 5 is, I put them in blue because the 5 is common to both lists, and the 3 is common to both lists. So these common factors occur in both lists, but they are not the highest, so they don't appear in the answer. 15 is the highest factor which is common to both lists. That's what we mean by the highest common factor. Now let's move on to see how we use prime factors to find the highest common factor. Just imagine that you had some very large numbers like this, 840, 930, and you were asked to find the highest common factor of these two numbers. Well, you could start writing out factors for this number, 840, and writing out all the factors of 930. Well, you can imagine how long and difficult it would be to write out lists of the factors of those two numbers, assuming you didn't even, you didn't forget one factor. But there's a very neat way of finding this answer using prime factors, and this is how you do it. You start off by breaking each number down into a product of its prime factors. So let's start with 840. Okay, let's do it down there. Here I'm dividing 840 by 2. It goes this number of times. This again will divide by 2 because it's an even number. Gives me another even number, so it'll again divide by 2. Gives me 105, odd number. So I go up to the next prime number, 3. 3 will divide into that. It'll go 35 times. 3 won't go into 35, so I go up to the next prime number, which is 5. And 5 will go into that 7 times. So I've now broken up 840 into a product of all its prime factors. Let's look at 930. Well, 2 will divide into it because it's an even number, and there's a 5 on the end, so I can't start again with 2. I have to go up to the next prime number, 3. 3 will divide into that, goes 155 times. 5 will divide into that 31 times. 31 is prime, so I can go no further. So I've now broken 930 up into its prime factors. What you do is this is where the little trick comes in. You now, if I get my hand out the way, there we are, you now write out the list of the product of its prime factors for 840, and underneath try and match it up, if you can, with its list of prime factors, the 930. Now you're looking for a way of finding the highest common factor. Now you'll notice I have got this 2 and that 2 in red. I've got this 3 and that 3 in red. I've got this 5 and this 5 in red. These are common prime factors. There, those 2 is a common prime factor. These 3 are a common prime factor. This 5 is a common prime factor. To find the highest common factor of 840 and 930, you take these common ones once only and multiply them together. You can ignore this, this, this and this. Just look for the ones which are common. So you've got a common 2, a common 3 and a common 5, and take them once and multiply them together, so that the highest common factor of 840 is going to look like this. 2 times 3 times 5 is equal to 30. So 30 is the highest common factor of 840 and 930. You have used prime numbers to find this. A very, very powerful method, and as I said, this was examined this year at GCSE level. Okay, we're going to move on to look at the lowest common multiple, and again we're going to look at what we mean by the lowest common multiple of two numbers, and then we're going to look at how we find it using prime factors. Well, let's do this with an example. Supposing you were asked to find the lowest common multiple of 5 and 6. Well, you could start by writing out all the multiples, big long list of multiples of 5. And don't forget, they will go on forever. You could then write out a list of all the multiples of 6, and here they are. Then what you need to do is to compare the two lists, that one and that one, and look for the multiple which is the smallest, or the lowest multiple, which is common to both lists. And clearly this red 30 is the lowest common multiple of 5 and 6. There are no other multiples which are common to both lists smaller than this. So we say that the lowest common multiple of 5 and 6 is 30. There it is there. So the lowest common multiple of 5 and 6 is 30. Now let's see how we can again use prime factors to find the lowest common multiple of two numbers. Okay, and again, let's move this up a little bit, get it nice and straight. There we go. Again, let's take an example. We've been asked to find the lowest common multiple, the LCM, of 45 and 60. Well, again, we start in exactly the same way as we did with the highest common factor. You break each number up into a product of its prime factors, and here it is. Okay, let's move it up a wee bit. I cannot start to divide 45 by 2, the first prime number, because 5 is odd, and I know 2 won't divide into this, so I go into 3. 3 will go into this, 3 will go into 15, and then we get to 5, prime number, stop. With 60, I can start with 2, 30, divide again, get 15, divide by 3, I get 5, 5's prime, stop. So we can write the list of the product of prime factors for 45 like this, and the list of the product of prime factors for 60 like this. Now, in this case, we cannot ignore these black ones. They have to be included. But the common ones, this common 3 and this common 5, we include once in the product when we multiply them together. So this common pair of 3 you take once, this common pair of 5 you take once, and each of these must be included when we multiply them together. So when we write, so the multiplication we do is this one. There's the 2 and the 2 and the 3 which are included. That's the common 3 to both lists, and that's the common 5 to both lists. Multiplying them all together gives 180. You have now found the lowest common multiple of 45 and 60 using the prime factor method. A very, very powerful method. Now, I promised you that we would look at the GCSE question that occurred this year, and here it is. This was question 2 from paper 6. It was on the edXL paper, and they asked, here's a summary of the question. It was to write 60 as a product of its prime factors, then write 96 as a product of its prime factors, then to find the lowest common multiple of 60 and 96, and then to find the highest common factor of 60 and 96. Well, very straightforward question, and by the way, worth 7 marks. So let's start. Bring that down a bit. So the first part was to break up 60 as a product of its prime factors. Well, 60 is an even number, so I can start dividing by 2. At 30, even. Keep on dividing by 2. 15. Odd. Try the next one. 3. Next highest prime number. 3. Goes in at 5. There it is, 5. So we can now write 60 is equal to 2 times 2 times 3 times 5. There it is. I think that was worth 2 marks. Not that difficult. Okay. Then part B of the GCSE question, we had to write 96 as a product of its prime factors. Here we go. 2 into that, 48 times. That's still an even number, so we can keep on dividing by 2. Yes, 24, keep on dividing by 2. Yes, 12, keep on dividing by 2. Yes, 6, keep on dividing by 2. 3, prime, stop, can't go any further. Okay, and so 96, written down as a product of its prime factors, is 2 times 2 times 2 times 2 times 2 times 3. You could have written this as 2 to the power of 1, 2, 3, 4, 5, 2 to the power of 5 times 3. But you would have still got the 2 marks for that anyway. Then the question in part C of the question was to write the lowest common multiple of 60 and 96. Well, how did we do that? Write down the long lists of the product of prime factors underneath each other. Okay, now I haven't this time put the common pairs of factors in red, but let's see if we can do it without. Well, look, I can spot immediately there's a common pair of 2 there. I can spot immediately there's another common pair of 2 there. Then there's a common 3. 3 there, 3 there, so that's a common 3. There are no common 5s. Now, how many common 2s were there? 1. So I take that one. Once only. How many common 2s here? Once. So I take 1, 2 only. How many common 3s were there? 1. So I take 1, 3. These other 2, 2, 2 and 5 must be included for the lowest common multiple. And here they are down here. This 2 in red corresponds to this common pair. This 2 in red corresponds to this common pair. The 3 2's here in black correspond to these 3 2's here. 2 times 2 times 2. There they are. This red 3 corresponds to this common pair of 3's. And then on the end we've got the 5. That has to be included. And now when you multiply them all together, you will get the answer. 480 is the lowest common multiple of 96 and 60. They then went on to ask you to find the highest common factor of 96 and 60. Well, again, you write the lists of the product of prime factors underneath each other. And this time we're looking only for the common ones. Well, there's a common 2. There's a common 2. And there is a common 3. All the others, 2 times 2 times 2 and this 5, can be ignored. So the list, the multiplication you have to do is 2, that's this red 2 here corresponds to that pair. This red 2 here corresponds to that common pair. This 3 corresponds to that common pair of 3's there. So, and the rest are all ignored. So the highest common factor of 60 and 96 is 2 times 2 times 3, which is 12. This whole question, a very simple question, was worth 7 marks. So as you can see, it's very much a part of the GCSE syllabus and a very easy thing to get some good marks for. Okay, that ends video tuition lesson number 1. I certainly hope that I've made it as clear as I possibly can. You, since you've paid for this, you have 1 month in which to view the lesson as many times as you can. I would urge you to try your own examples based on what I've shown you, just to reinforce what I've actually shown you, so that it gets embedded in your own understanding. The more examples you do for yourself, the more it will make sense. Okay, thank you very much.